So hi everybody, my name is Sharon Nagar. I'm a product line manager in CSG in Broadcom. CSG is the core switching group. Basically, we're doing all the switching and routing in Broadcom. And I'm very excited to be here on the Cloud Field Day. We're going to be talking about our new 25 terabit per second router. And that is called Qumran3D. So before we start, a few words about Broadcom and the CSG, the switching and routing team in Broadcom. So as some of you may know, we have three main product lines in our team. We have the Trident, the Tomahawk, the Jericho. And basically the idea here is that we have optimized devices for the different market segments, different use cases. There could be some overlap between them, but basically each one of the product lines is optimized for its use cases. All of these devices work on common infrastructure in our team. That includes the SerDes, the connectivity to the devices. It includes different features like enhanced telemetry features and the core of the software that we provide, which is called the SDK. So this is a few words about what we do. And in this Cloud Field Day, we have three presentations. For those of you who missed the first presentation on Trident 5 X12, you should download it and look at it. I will be presenting the Qumran3D, the 25 terabit router that we have. And we will have another presentation on the NIC platforms for AI platforms. So let's talk about Qumran3D. This is the device. Basically, this is a 25 terabit router. So think of any network where you might have seen the platforms with plugs coming in and out. This thing runs a 25 terabit network. This is basically 32 ports of 800 gig you're holding in your hand. And this is not just a switch, it's a full carrier-grade router with all the capabilities you can think of. It has deep buffers on that chip itself. It has huge amount of databases for routing. This thing can hold the entire internet routing table on the chip itself. You don't need any external devices. We also have encryption engine on this. So all this 25 terabit that runs in and out of this device can be encrypted. It could be MACsec, it could be IPsec. Again, there are millions of counters on this, so you can actually understand what's going through this device, et cetera, et cetera. So we'll talk more in details about all these technologies inside this device, but let's first see where it came from. So some of you might have heard about the Jericho line. This is basically the de facto standard nowadays for any chassis or modular type system out there. These things run on the Jericho product line. This product line has been in the market for more than 10 years. It's been multiple generations that we've been through. The latest devices that are already out there are the Jericho 3, and we actually have a Jericho 3 AI, which is an optimized device for AI networks. Again, as I mentioned, this product line has been there for many, many years. A little bit less known is a parallel product line called the Qumran. This product line is for what we call fixed type devices or fixed type platforms. It's actually a centralized device that all the switching is done on a single device instead of using larger type of fabrics, etc. This product line has been there for 10 years now. The latest Qumran3D, the 25 terabit router, is actually 100 times faster than what we had when we came out 10 years ago. Not just that it's 100 times faster, it's 95% more efficient when you look at the power that it takes. So these are amazing. The advance of technology in the last 10 years is just amazing. Now, as I said, not many people know.
Yeah. Again, 100 times faster and 95%
yes.
less power.
It's more power efficient. So if you take the power per bit, it's 95% less. Yes. So again, this product line might be a little bit less well known. I think more people are familiar with the Jericho line. But as you can see in the slide, there are many, many platforms already out there with different devices from this product line, the Qumran product line. OK, so let's look a little bit about what's inside this device. So as we mentioned, there are 256 100 gig PAM4 SerDes here. So that means you can connect 256 100 gig lanes or 100 gig Ethernet. Or, of course, you can have multiple different capacities or speed for the ports. So you can have 800 gig ports, you can have 400 gig ports, etc. Again, it's hard to imagine that you have 25.6 tera on a single chip and doing all the routing capabilities. So this includes basically our Jericho pipeline, which is the most advanced out there in the industry, doing carrier-grade feature set for all the routing needs. It has deep packet buffer. So on top of the standard buffer that you usually have on a switch, here you have an extra HBM, a few HBMs that allow you to even buffer more. There is a traffic manager built into this device that allows you to do hierarchical traffic management. You can do all kinds of priorities. All these things are built into the feature set. Security, as we mentioned, there's an embedded security engine in this device, so you can do encryption and decryption of all the traffic. And this is done for all the traffic. You don't need to choose, OK, I want to choose only part of the traffic. All the 25 terabit can be encrypted. And there are a few things that are new with this generation. So one of the things is, for those of you who are aware of previous generations, we had a companion chip that used to sit next to our routers and will allow you to do expansion of the forwarding tables. This is basically your IP route lookup. So usually on chip, due to the amount of stuff you can fit on the chip, you would be able to put a certain size of routing table. But in the internet, there's more. So you would have to install another chip next to this to expand those tables. What we did in this device, we actually integrated that expansion into the device. So we'll see in a few slides more details about the size of the things. But we have more forwarding capabilities. We have more ACLs. ACLs are really the policies that you put into configure your router or switch. You want to say, OK, this traffic can go this way, this traffic can go that way. This traffic, we don't want to let it go through anyway. So these, also, we expanded the amount of ACLs that we can put there. So there's more than 1 million rules you can put on this device just for these policies. And the counters, which I spoke about. There's millions of counters on this device. And again, we'll see in the next few slides more details on how those work.
So basically, every time when you find this Qumran3D chip in a device, any device, technically you have access to all those features, but they can be limited by the software edition.
Yes. On top of this, basically, when you think of a router,
yeah, you have
the box, you have the connectivity,
Yeah.
you have the hardware engine that does everything. This is the Qumran3D. And on top of that, you have somebody building the software to run everything.
Exactly. And this software can be sold in different versions, give you access, for example, for MACsec.
Yeah, then that's already our customers are usually the OEMs, the people who build these platforms, and then they use whatever. They can do different software features, they can have different licensing features. That's up to them of how to use that.
Gotcha. Thank you.
Okay, so let's look at some of these advances that we made, and let's see how these also apply to cloud networks. So we're in a cloud field day, so let's talk a little bit about the cloud. So one of the things that when you talk about cloud, you talk about virtualization and multi-tenancy. Basically, you have a certain platform, let's call it. You want many people to use it because that's the way you make more money. But you want each person using it or each service using it to think that is the only one using it. You don't want them to see one another. So that is all done with different, by using different routes, different rules, different tunnels over the device. This device has hundreds, tens of thousands of virtual routes that you can put in it. There's thousands of tunnels that you can define in it. So basically, it allows you huge amount of number of different services, different customers using this device. And it is all modular and flexible. So whenever you write, the customer that writes the software for this can allow you to configure and basically provide different applications to run on the same device. Another thing is the routing table. We mentioned it a little bit, but let's see the numbers. So what you see here is the projection of the internet routing table, the number of routes you will have until 2030. And this includes IPv6 and IPv4 routes. As you can see, the sum total of them is the red dotted line there, the black dotted line there. And you can see the Qumran3D has capacity for much, much more than that. So this basically means if you now install a router with this device, you don't want to be in a need to next year put a new device because you don't have any space to configure. We have enough space in here to configure stuff for the next few years. As I mentioned, there's over 1 million ACL rules. So basically, the number of policies that you can put on the router. This is a huge amount. It's a dedicated resource in the device, and you can use it in multiple ways. You can use it for differentiating between different subscribers, different applications, different services. You can use it as security policies. You know, if there's a specific signature, you know that this is bad packets, you can just put it there and it will drop it. So again, this is very important for the security of the subscribers. On top of this, as I mentioned, we have the encryption engine that allows you to decide for each of the flows going through the device whether you want to encrypt it or not, and what type of encryptions.
Quick question on the policy side.
Sure.
I'm just wondering from Broadcom's perspective, if cloud providers are aligning, say, energy consumption, power consumption policies with this type of implementation.
So yes, power and energy consumption is very important these days, especially as all these devices go much, much bigger and consume much more power. So there are some capabilities to decide on the way the device will work at certain power levels. that is not, those are hooks that are in there in the device. It's not very common at this stage. What is much more common is, first of all, the device itself automatically adjusted. It doesn't use the same power all the time. If there is less traffic, the device will automatically use less power. Those things are built in. And again, the integration that we do in this device, the fact that we have all these different mechanisms together in the same package, that also saves a lot of power.
Good to know. Thanks.
Sure. The next thing I wanted to talk about is the counters. So as I mentioned, we have millions of counters on this device. And counters are important for whenever you have different services or different subscribers or different users, you want to see what they're doing. So you want to count the packets, the bytes, you want to meter and make sure that this guy doesn't get more than what he should have, things like that. All of that, you need counters. Of course, since you have millions of counters, you can have many, many subscribers. That is one thing. Another innovation we added here is what we call the state counters. So these are not regular counters, just count what went through the device. They also remember the state. What does that mean? For example, if we have a denial of service attack, and again, I'm talking about a simple denial of service attack where you see a lot of TCP SYN coming in and there's no ACK and basically blasting the device. So whenever we get the first, for a flow, we get the first TCP SYN, we can mark in this counter that this is, okay, this is the first one. This is a new flow we're learning. Now, if we get an ACK, then okay, fine, this is okay, everybody's happy, we let this traffic go. If we don't get, we get more and more SYNs on this flow, we now move this counter to a new stage. This is now, okay, something might be fishy here. And we can wait, we can decide, we wait for five SYN packets, we wait for 10 SYN packets, whatever number we decide. After that, if we still don't get an ACK, okay, this is a bad traffic flow, we're going to drop it. All of this can be done by the hardware, again, and we have enough resources on the device to allow for such thing. And we have the stateful side of the counter. So we remember what happened before we started counting, or what happens now when we're counting this. Okay, the next part is how do you connect this chip that you all saw to actually to a network? We need some optical connection or some copper connections. This is usually done via optical devices. Now, as I mentioned, the device uses the 100 gig PAM4 SerDes from Broadcom. These are industry-leading SerDes. And you might say, okay, you know, there's an IEEE standard. Who cares? If it meets the standard, it's fine. The idea is that we don't only meet the standard, we exceed the standard, and that gives the operators the ability to use different type of solutions. For example, the linear drive optics that drive the power way down. You can use coherent optics, which gives you extra long range for data center interconnect, for example. You can use co-packaged optics with this device, where the optical interface is actually coming directly out from the chip. And you can use the extended reach copper cables, which allow you to, with this case, we can do up to 4-meter DAC cables. So this basically means as long as you're in a rack, you can actually use copper cables. You don't need to use the more expensive optical cables. So these are a lot of advantages for the operators, wherever they are, whether the cloud operators or other operators, to save on the overall total solution once they deploy these type of devices. So as you saw, this device is very, very flexible, and it allows all kinds of different applications to run on it. So we can actually use it not just in data center settings, in cloud settings. We can also use it in service provider areas, whether it's aggregation, internet peering, provider edge type applications, many applications throughout the networks. And each of the application usually has their must-have feature set, which is in the green here, nice-to-have features, which are orange. You can see here different features that we have on Qumran3D, different applications, and how these map. And as you can see, Qumran3D can do all of these features and flexibly meet all these applications. Bottom line, I don't know how many of you saw lately 64 ports of 400 gig router, but the ones that are out there today are usually a pretty big, sizable chassis with multiple line cards. Usually in them, you will find between 12, 16, or even more silicon devices, chips. All of this can now be done on a single device. So we're not only saving amazing amount of power and space. Think about it, when you have multiple devices in a system, and you need some, as you asked before about the software, something needs to control all of this. When it's all distributed throughout the chassis in multiple devices, it's much harder to write this software application. You need to take into account different parts that you need to configure. Here you have a single device, much simpler way to write the software. It's a small pizza box type device, and it does the same thing and even more.